Okay guys, I'm going to record this number 15 because a lot of people have trouble with this, but it's just because they overcomplicate it. Right. There are two tanks on a property, tank A and tank B. Initially, tank A holds 1,000 liters of water and tank B is empty. Tank A begins to lose water at a constant rate of 20 liters per minute. Right. The volume of water in tank A is modeled by V equals 1,000 minus 20T, where V is the volume in liters and T is the time in minutes from when the tank begins to lose water. On the grid below, draw the graph of this model and label it as tank A. So let's go down here. Right, we could do it the first way of just doing, plotting the points. So we could just plot this and then just go down 20, right, and across 1. Do that for the whole thing, but I'm just going to write a table of values because I think it's quicker. Right. So we have T and V. Right. Put it for different points. So let's put it for 10, 30, and 55. Right. So when T equals 10, we just put 1,000 minus 20T. Right. We sub this T for 10. So we have 1,000 minus 20 times 10. 800. Do it for 30 as well. 400. 55. Get minus 100. Right. So maybe 50. Yeah, so for 50, we get 0. Right, so we just plot these points, 1,000, 10 and 800. Next here, 30 and 400. 50 and 0. Draw a line between them. Perfect. And then I think that's all we need to do for that one. Yeah, easy. All right, so next one. Tank B remains empty until T equals to 15. So when water is added to it, at a constant rate of 30 liters per minute. By drawing the line on the grid or otherwise, find the value of T when the two tanks contain the same volume of water. Right. So for this, you could do it with the substitution method, or you could do it with drawing the line. Right. So doing that for this question, tank B remains empty. Right. So for this one, let me just make sure this is in sync. Perfect. All right. So tank B remains empty until T equals 15. Right. And then water is added at a constant rate of 30 liters per minute. Right. So you can say volume equals to 30 liters a minute. Right, no y-intercept, right? And I'm just going to write a table of values. We could do it. So the only thing for this, right, do not overcomplicate this, right? This isn't hard, right? Just think very, very simple. Right? Instead of starting this graph over here, we're going to do the same thing, but we're going to start it here, right? So this is going to be our 5, this is going to be our 10, this is going to be our 20, right? Do not overcomplicate this, right? It's not that hard, trust me, right? And so this is our 1, right? So we're just going to draw a table of values real quick. So 5, 10, 15, right, and then V here, and then just sub everything in. So 30 times 5, 150, 30 times 10, 300, and then 450. Okay, so after this, we're going to plot these like respectively, right? So instead of writing t equals 5 and then 150 here, we're just going to do it 5 away from this. All right. And then for 10, instead of doing it 10 away from here, we're doing it 10 away from here. Right. So 25 is going to be 300. 15, so the corresponding value here is going to be 450. Right. So let's just draw a line through here, like this. Right. And so drawing a line or otherwise, find the time when they both contain the same amount of water. It's going to be about here. So about 29 minutes. Right. Do not overcomplicate this. Another way you can do it is solving them simultaneously. Right. So for this, we have to find the y-intercept. Right. So v equals to 30 t minus oh, that's the thing. We have to find the y. I can't be bothered. All right, doesn't matter. Right, we'll move on from here. Using the graph drawn or otherwise, find the value of t, where t is greater than 0. The total volume of water in the two tanks is 1,000. Right, so I'm just gonna draw this out. I hope this is accurate. No. I just don't want to draw a table of values for each of these. Right. Let's just pretend this is accurate. Pretty sure this goes up here. Let's try and draw this straight. Perfect. Okay, so we've got this here. Let's just extend this out a bit more. Right, pretend that's straight. Right, find the volume, find the value of t where t is greater than 0. So t is on this side of the line. Right, greater than 0, so it must be in these values here. When the total volume of water is 1,000. Right, so this is just trial and error. We could find this here, see how much volume of water is in here, just 700. How much volume of water is in here at 40 minutes? Right. That's like 730 plus 200. Right, that's not 1,000. What about here? Just because I know the answer. Right. Just trial and error. Here at t equals 45. Right. 900 plus 100 equals 1,000. Right. So we'll say use a graph or otherwise to find the value of, for example, where t is greater than 0, and that is at time 45. Right, minutes. Right. Easy stuff. Let's make sure we got everything. Yeah, perfect. Okay, so that's been this question, right? Have a go at others, right? Work your way through these, right? And then, just keep going, right? Do as many questions as you can, mark them, look at the answers, see how you went wrong, so you can really nail these down, right? So I'll see you in the next